scalar multiplication of a matrix. The scalar multiplication of a matrix is quite simple and easy topic. Today we will see how we can multiply a scalar with a matrix. Then we will see the properties of scalar multiplication. Also we will discuss two examples to understand the concept more efficiently. So let's get started. Let k be a number. K be a number. It may be real or complex, called scalar. That k number is called scalar, and A be any matrix, right? Then the matrix obtained, from A by multiplying all its elements by k. Then this k is called scalar multiple of A by k, and it is denoted by k into A. Let k be a number. It can be real or complex. It is called scalar, and A be a matrix. Then the matrix obtained from A by multiplying all its elements by k. Then k is called scalar multiple of that matrix A by k and is denoted by ka. Like this. Now what does it mean? Suppose we have a matrix A. Suppose its elements are A, B, C and D, right? And we have a scalar k, right? So to multiply a scalar k with this matrix A, B, C, D, this is matrix A. So Ka will be multiply all the elements with this scalar, and we have Ka, Kb, Kc, Kd. So this is how a scalar is multiplied with a matrix. So now we will see what are the properties of scalar multiplication. The first property is associative property. Associative property. It says if A is a matrix and lambda or mu are scalars, then lambda times mu of A is equals to lambda mu into A. It means associative property holds for scalar multiplication. Next property we have is distributive property. In distributive property we have two categories. If we have one matrix and two scalars, distributive property holds for scalar multiplication. Similarly, if we have two matrices and one scalar, still distributive property holds for the scalar multiplication. Let's check. If A is a matrix and lambda and mu, these are the two scalars, then according to distributive property, we have the scalar lambda plus mu into A. This is equals to multiply the value of scalars with the matrix. This is scalar, multiply it with the matrix. We have lambda A plus mu. This is a value of scalar, multiply it with the matrix. We have mu of A. So when we have two scalars and one matrix, distributive property holds for the scalar multiplication. And the second case is if A and B are two matrices of the same order and lambda is a scalar, then we will multiply the value of scalar with these two matrices like this. Now multiply scalar with the matrix. We have lambda A plus lambda B. So distributive property holds in this case also. Now let's take an example. This is the value for the matrix A and this is a scalar. To multiply scalar with a matrix A, let's see how we will proceed. So multiply the value of this scalar with all the elements of the matrix A. We have 3 over 4, multiply it with the first element 12, then 3 over 4, multiply it with minus 8, 3 over 4, multiply it with 8 over 3. Similarly, now multiply this term with this whole row. 3 over 4, multiply with minus 16, 3 over 4, multiply it with 36, and 3 over 4, multiply it with minus 32. We will do the similar procedure for the last row. Now we will simplify it. 4 1 times 4 and 4 3 times is 12. So 3 3 times is 9. 4 1 times 4 and 2 times 8. So 3 into minus 2 is minus 6. 3 and 3 will be cancelled out and 4 2s are 8. Here we will have 2. 4 1 times 4 and 4 4 times is 16. So 3 4 times is 12. 4 1 times 4 and 4 9 times is 36. 3 9 times is 27. 4 1 times 4 and 8 times is 32. 3 8 times is 24. 3 1 times 3 and 3 3 times 9. 4 1 times 4 and 4 5 times is 20. So this is 5 over 3. 3 5 times is 15 and here we have 15 over 4. 2 1 times 2 and 2 times is 4. So here we have 3 over 2 answer. We have another short example, very short and easy. This is the value for matrix, suppose A, and this is the value of scalar. So simply multiply the value of this scalar inside the matrix. This is 4 over 7. Multiply it with the first element which is minus 22. Then multiply minus 4 over 7 with the second term of the column which is 49. Lastly multiply 4 over 7 with the last term of the column which is 35. Right? So 4 into 22 times is 88 and minus minus times is plus. So 88 over 7. Then we have 7. 7 times is 49. So 7 4 times is 28. Here we have 7 5 times is 35. So 4 5 times is 20 and a minus sign. So in this question we don't have any row, we just have a column. Still we can multiply a scalar which is given to us. If we are not given any column, we have this row, Then we can multiply a scalar in 2 cross 2 matrices, in 4 cross 4, 3 cross 3. In every matrix, scalar multiplication is possible.